I hope you're having a nice evening. Tonight we're going to take a look at transformations of exponential functions. We've been studying transformations pretty much all year, but let's see how transformations work with exponential functions. So let's start off with one of the parent functions. So here we have y equals 4 to the x power. So remember that you have an exponential function when the variable is in the exponent, okay? And your b value needs to be greater than 0. Actually, and it cannot be 1 either. So if we want to transform this, we would write this. The transformations would be found like this. We'd have our a value like normal in the front being multiplied times the base, which in this case is 4. And then our horizontal effect is going to be found with the x in the exponent. So we would have x minus h, there's your horizontal translation. Remember that if you're multiplying by something, we would need to factor it out. So since we're using b, we'll use capital B for the base here. We'll use little b here for our horizontal stretch and compression. And then we have our k value on the end. So again, our vertical effects are found with a and k. And then our horizontal effects are found with h and lowercase b. And our capital B would be our base. So let's say that we want to take this function here. Let's say that we want to have a horizontal translation, left 4, down 2, and a vertical compression as well. So how would we write that? So the base for this parent is going to be base 4. We want to go 4 units to the left, so we would do x plus 4. Remember, it's still always the opposite. When you do have x in the exponent, an exponent, when you have multiple terms, acts like a group, just like in quadratics, a grouping symbol. Okay, we have a vertical compression, so we're going to be multiplying by a number between 0 and 1. So let's say 1/7. And then it's translated 2 units down. And so there would our function be. Vertical compression, translated 4 units to the left, and translated 2 units down. Okay, let's take a look at another example. Okay, let's go ahead and write the transformations for this function. Remember that when the negative is in the front, we would have a reflection across the x-axis, because since we have a vertical effect, it's changing the y values. So if the y values were positive and you multiply by negative, they become negative. So it's reflecting across the x-axis. 3, there's your a value right there. And since it's greater than 1, we have a vertical stretch. The base tells us that we have an increasing function. And here, remember that when you have two horizontal parameters, you need to factor out the number in front of the x. So factoring out the 2. Remember, factoring is division. So now we can see that we have a horizontal compression. And it's translated 2 units to the left. And translated 5 units up. And there you have it. Okay, let's take a look at example 3. Rewrite y equals 25 to the x power using base 5. So if you remember when we were solving exponential equations using like bases, basically we want to just change this 25 to base 5. So we know that 5 squared is equivalent to 25. And then that's raised to the x power. So then we would get y equals, at power to a power you multiply, and so this would be our equation, base 5. Now how would we graph this? Well, if we were to graph this by hand, so I'm going to go ahead and use this function right here. If I wanted to graph this by hand, first thing I would do is I would start off with the parent function and then perform the transformations. So the parent function for this is y equals 5 to the x. It's basically the base raised to the x power, not including any of the transformations. So again, choosing some negative and positive numbers. Okay, so we'd have negative 2 in for x, so we'd have 5 to the negative 2 power, which is 1/25. Plugging negative 1 in, we'd have 1/5. Plugging 0 in, 1. Plugging 1 in, 5. And plugging 2 in, 25. Okay, so these are going to be our y values right here. So now that would be your parent function if we plotted those points. Now what about our transformation? Well, we have a horizontal compression, so we want to multiply all our x values by 1/2. Remember, horizontal is the opposite, so if it's times 2, then we need to take half of all our x values. So taking half of all our x values, we get negative 1. Half of negative 1 is negative 1/2. Half of 0 is 0. Half of 1 is 1/2. And half of 2 is 1. So now that we have our new x values, and notice that y has not been affected, so we would stick with these y values here. And then we could plot these points, and we would have our graph for y equals 5 to the 2x power. Alright, I would graph this, but this is what we covered on the previous night's video notes. And so if you do have any questions, please come to class prepared to ask. Hope you're having a good evening. See you guys tomorrow.